This is the luckiest maths teacher in the world. Thank you so much for tuning into this video. By the end of it, you should be able to solve problems involving parabolas. So let's do this problem in blue. The perimeter of a rectangle is 36 centimeters. What is its maximum possible area? So you're probably thinking, well, what does the area of a rectangle have to do with a parabola? Well, it's because this word maximum. Remember, parabola always have a maximum value or a minimum value. So they're very useful in solving problems like this. Before we get to that, let's look at a bit of intuition. So we have a rectangle here, and we're told its perimeter is 36. So the distance around the outside is 36. So that means that this side and this side, the length and the width, must add up to 18. These two add to 18. Plus 18 more gives you 36. So the width and the length add to 18. So we could have, for example, one that is 7 by 11. And if these are in centimeters, the area would be 77 centimeters squared. So we could also have something like 5 times 13. And if these are in centimeters, the area would be 13 times 5. So there is a maximum value that we can get for the area, and that's what we're trying to find here. So what we need to do in order to find the area of any rectangle, we need to know its width and its length. So let's start off by letting x equal one of those. I'll let x equal the length of this rectangle. So to find the width, we only need to subtract the length from 18. We saw here, if the length was 11, the width was just 7, 18 minus 11. If the length was 13, the width was 18 minus 13 equals 5. If the length is x, then the width is just 18 minus x. So now we can easily write an expression for the area. So let's let y be the area of the rectangle. It's just going to be length times width. And if I expand this, I just get 18x minus x squared. So now you can see we have a quadratic equation here. So if I were to graph this, I'd obviously get a parabola. Now, because the value of a, the number in front of x squared, is negative here, it's -1, if I were to graph this as a parabola, it would be concave down or a frowny face. So that means it has a maximum value. We are looking for this value in this question. Now, the question didn't actually ask us to graph this function here, y equals 18x minus x squared. I won't do that here because I don't want to take up too much of your time, but I do have another video on graphing. All we need to do here is find the maximum y value. So that will be at the turning point. So remember, the formula for the turning point of any parabola is x equals minus b over 2a. That's the x value. So in this case, b, which is the number in front of x, is 18. So x will be minus 18 over 2 times, and as I said before, the number in front of x squared, which is a, is -1. So we get x equals 9. The maximum turning point occurs when x equals 9. So to find the y value, all we need to do is take our value x equals 9 and sub it into this equation. So y would just be 18 times 9 minus 9 squared. We don't put brackets here because I'm not substituting x for a negative, I'm substituting x for positive 9. So if you put that on your calculator, you should get 81. The maximum possible area is 81 centimeters squared. And that occurs when x is 9. So the length is 9 and the width is 9. So this would actually be a 9 by 9 square. Now, before you're like, wait, you didn't say it could be a square. A square is a type of rectangle because it's a four-sided shape with all angles equal. All right, let's look at one more example. So a company that wants to sell an Xbox game has modeled the number of games they sell is given by the equation y equals 800 minus 5x, where y is the number sold and x is the price per game, and we want to know at what price they should sell the game in order to maximize revenue and what is the maximum revenue. So let's look at what is happening here. So this function, y equals 800 minus 5x, is actually a linear function. If I were to graph this using the XY intercept, it would look like this. Of course, I only need to look at the first quadrant, positive values of X and Y, because the price is always positive, so too is the number sold. So here the gradient is actually -5. That's easy, it's just the number in front of X, because it's in the form Y equals MX plus B. This means that each time you increase X, the price, by $1, you lose 5 customers. You sell 5 fewer games. So this actually makes sense from a common sense standpoint. The number you sell isn't just fixed. The higher the price, the fewer you sell. So if this is a linear function, how can we find its maximum? Well, we're looking at the maximum revenue. This equation only tells us about the number sold. So if I want to write an equation for revenue, I'll just call it Y star. This will be the revenue. The amount of money you make is simply the price, which we said was X, times the number sold. So I can expand this. I get that the revenue, Y star, is 800X minus 5x squared. Of course, this is a quadratic equation. As such, it will have a maximum or a minimum. Once again, because the number in front of x squared is negative, that means it will have a maximum turning point. We have done all the hard work. All we need to do is exactly like we did in the previous question. We find the maximum by using the formula x equals minus b over 2a. So b is 800, so it's minus b over 2 times a, and that should give you 80. So what that means is revenue will be maximized when the price is 80. So when you're selling each game for $80. So the revenue, the amount made, I just substitute 80 into this equation, as I did in previous examples. So substituting x equals 80 into this equation, we get this, and putting that on your calculator, we get 32,000. So if I substituted x equals 80 into this equation, 800 minus 5 times 80 is 400. What I'm saying is this company will maximize revenue if they sell the game for $80 each, and then they will sell 400 of them, and they will make 400 times 80, which is $32,000. Thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.